Right. Okay. So as whatever seventh hour is doing, I'm just gonna talk to the computer. Then anyone in seventh hour that cares to listen, they'll be in good shape. Anyone that doesn't, listen to them. Just listen to them. Nothing. Okay. Actually, I didn't even put the calendar up yet, and that's good. Shh. Silence. Okay. So I'm gonna cut and paste, but I gotta add. So the original idea was this, and I also want to show you this. Shh. Still. Part of your assignment does come from 1-4, but then look at that worksheet that I gave you. The other teachers were worried about radicals and stuff. So on my chair. That's good. That's good. Okay. Worried about radical stuff. So I kind of called combination of their worksheet like 1-3 B or something like that. Doesn't it say B on it or so? I don't know. It does say A. All right. Well, it is like day 2 worksheets, and I got to get this up here. But you have it in front of you. Shh. And I'm just going to do a couple things from there because they were worried about simplifying radicals. So, and I think that's a good worry, that you know how to do that well. But then turn over that worksheet, and then this one exists. Good stalling. Man, that was fast. Just a battery in there, right? Not a new pen. All right. Let's see how it looks. Looks pretty good. Okay. So on the back of that worksheet, there's that assignment. I want you to do it on that back. By the way, what does it mean? 3 through 15, malt 3 or malt of 3. Malt was of 3. So what do you do after number 3? 6, and then what? 9, and then what? 12, and then what? 15, and then it does that in the next section, and it does that in the next section. So just a way to like just get a little few examples of each kind from each section in there. Okay, so that's what malt of 3 means, so we don't mess that up. Next, time for notes, and I'm going to go fast. As a matter of fact, I'm not going to do that. That's a repeat. So say it. So say it. So katoa, and then what do we do? Sir, say it. Kicks or ticks. And then this is kind of what you put at the top of the test, so you get the right ratios. And then I'm going to do this in green. Maybe I'll do this. I had this idea instead of like cosec. Okay, what's cosecant? Cosecant's a what? Oh, you're all afraid to say it. Oh, I don't want to be naughty, Mr. Samulus. So that means cosecant of an angle measure is equal to. This is why you still write so above cosecant questions, because then it's actually what letter over what letter? H over O, or, oh, shoot, sorry. H over O or R over Y, one or the other. And that's how you handle it. So even in cosecant, secant, and cotangent questions, I still write so katoa above those, and then deal with what they are. This is a review, by the way. All right, and then secant is related to tangent, so secant is or r over x. So if this never fit, what I was saying with these, you got to get those down now. So that's why I still write kicks are above a secant question, but then do an arrow going in an opposite direction for r over x. Ran out of room for cotan. Now I could sneak it in here. Cotan of theta equals, well, ticks or toa, but in reverse. A over O or X over Y. So a lot of questions of that last hour, even after going over from some things. So I thought that'd be a good start for you. Now, I'm not doing all 3 of these. I'm going to look at this first one. Look at your homework. You don't have to write this down. This is review. This was day 1, Tuesday last week. Okay, how do I solve for this triangle? By the way, do understand that there's no coordinate plane. So this is flat out SOHCAHTOA. There is no sign problems, positives, negatives. No negatives could be possible in these kind of questions. So why did I pick this one and not the other 2? because I like that this happened. By the way, what side is this? Opposite? Oh, wrong. That's hypotenuse. You're right. It's opposite the 90 degree, but it's hypotenuse. So someone said the opposite, and I accidentally wrote that. Okay, answer this question. What side is this? Because that's what Danny had to do in high school. So it's not opposite that's left over. What's left over? Adjacent. So I don't write that. I go, oh, okay, that's opposite. So that's adjacent. Who deals with A and H? Which trig function? Cosine. And then don't worry about secant on these questions because you don't have a secant button on your calculator. So you pick the original one, cosine, and you cosine the angle measure, and that equals A over H. This is why I did this. Now, unfortunately, I took Karen Cooper's worksheets and I cut out some questions, and I unfortunately cut out the wrong ones. I wanted ones that had the variable in the denominator. Darn it. Because what happens when you have the variable in the denominator? Da-da-da-da-da-da. That's the Get Triggy With It video. Literally in that section, it does do that music. Da-da-da-da-da-da, and switches these two. And that's something we should be able to get fast with in this class. If x wasn't in the bottom, then you multiply both sides by the number. And that's when it's multiplied. This one's division. And then you type that on your calculator. I delete your calculator memory. What happens to your calculator goes in what? Radians. What do you have to do right away? Mode. And then change it to degrees. You're right. No, you're right. You're right. I just wanted to tell you the button that you hit. Just hit mode on your calculator. Someone last hour goes, how do you do that? And then guess what Mr. Samuelis did? Yelled. Because you weren't, when I was doing it the other, you didn't take your calculator out and you sat there with your arms folded, and that's why you don't know. All right. Here's this section. This is what the other math teachers were worried about. Can you deal with the radical? And these things happen a lot. Okay, so what's 72? What times what? I bet you picked not a good one, but go ahead. 9 and 8. Not good enough. There's a better one. 12 and something is still not great. There's a better one. Divided by 2. 2 times what is 72? Oh, no, we don't even know that, do we? 2 times what? No. 36. No, even if you did 9 times 8, I would take 8 and know that it's 2 times 4, and then take that 4 and that 9. What's 4 times 9? I would still get to this. Because when I ask anyone, what's the square root of 36, and everyone can answer it, then that's how easy this question is. What's the square root of 36? 6. So this is 6 free times square root of 2 stuck. It always blows my mind how many students cannot deal with these radicals when everyone in this class can answer what the square root of 36 is. So when I teach simplifying radicals, I teach try to, with your calculator, find the biggest perfect square. All right. And then simplify that out. And then anything else is stuck in jail. By the way, we already have fractions. I'm going to give you my 3 R's like a horrifying infomercial. Hey guys, when you have fractions, you can either root it, reduce it, and then what do you ultimately have to do with fractions and radicals? Starts with an R, not recycle, R-A, R-A-T, come on, rationalize it. And this is on purpose, last. Anyone that had me last year, they know this. We did this in Math 2 Honors. It's the only person I could have in this class, anyone from Math 2 Honors. We had a big radical section, and it's a Math 2 concept. Okay, but that does not apply to this one because there is no radical in the denominator. So what we have to do is simplify the numerator. What's 45? What times what? We better get this one right away. What's 45? What times what? 9 and 5. What's the square root of 9, everybody? 3. Pick 3, sir. But then 3 over 12 does cancel to 1 over 4. So that's not the root it, rationalize it. You just had to simplify the radical. The root it, reduce it, rationalize comes when you have a radical in the denominator. And for some reason in math, this is not allowed. You cannot leave this as a final answer. By the way, is the square root of 3 simplify? Yes or no? Does it root? Is 3 a perfect square? Yes or no? No, there's nothing to reduce. So you must rationalize, and I already showed you this on Friday. I just kind of inserted that in real quick. Hey, everyone needs to remember how to rationalize, which means you have to multiply top and bottom by the same thing because that equals 1. You've actually multiplied that by 1. All right. And then what's the numerator become? It becomes root 3. This is the last time I should have to write this. What's root 3 times root 3? Root 9. What's the square root of 9? Which everyone can answer. We should not have to write this anymore. It was the whole point of writing and rationalizing. All right. It was the whole point. So this is a math basic skill that's needed when you're dealing with radicals. And we are keeping these questions small, but then they went to their homework and they went nuts. So I'm actually going to do a couple of your homework worksheet questions. This doesn't deal with, well, can I root the square root of 2 right now? Is that a perfect square? No. So there's nothing to reduce because I don't have a radical over a radical. So I have to rationalize. So it's root 2, both top and bottom, because that equals 1. I've multiplied it by 1. I'm going to keep reiterating that. And then I'm not writing root 4 on the bottom. The whole point of root 2 times root 2 is to free it. I've already had this. What's root 2 times root 2? 2. What's root 7 times root 7? 7. What's root negative 1 times root negative 1? Negative. No, negative 1. That was proving I squared equals a free negative 1. I've already done that. And that's when I put those things down about why is root 2 times root 2 equal to 2, just like root negative 1 times root negative 1 is a free negative 1. This is the why I squared equals negative 1. You should not be rolling your eyes on these things. These are things that are supposed to be like the back of your hand right now. This is all stuff you're supposed to own and be professionals on. All right. Does root 3 over root 7 reduce? Do 3 and 7 have anything in common? No. And do any of them radical? Can I simplify them? Are they perfect squares? So this is another sad rationalize. But you know what? I'm done. We too much of this rationalizing. This becomes 2 root 21 over a free 7, and that's it. Doesn't look any better, but that is considered simplified. Now we get down to it, and then I'll show you hard math questions that they went nuts with you here. Does root 12 or root 2 root perfectly? Yes or no? This is what I mean about root it. No. Do they reduce? Meaning this could be written like this. I'm kind of like going over this like a couple rules that are pretty specific in radical land. We could write this as one big root 12 over 2 because they're both underneath the radical. You don't need to though. When you have a root over a root and they reduce, you can reduce them. So how many times does 2 go into 12? 6. And for the love of dog, what is the square root of 1? This always drives me nuts. What's the square root of 1? 1. Don't ever write that as a final answer. Okay, that is actually, I don't like it. It's actually wrong. It's not simplified. All right, root 1. I get so many students write root 1 as a final answer. So I didn't need really this. I could root over root. I can cancel them right now. And then notice what happens. 6 times root 1, which is 6. This is done. So actually reducing, maybe not have to rationalize. All right. Now, you want to get nuts? They got nuts. They gave you this. I just gave away what that was. Let's see if I got rid of the next one. This is number 12 on your worksheet. So, and this was Mrs. Cooper that came up with these, and then in the worksheet they got a little bit more challenging. I wouldn't say this one's really challenging because, well, first of all, root it. Do you think 3 is a perfect square? No. Is 243? Then the next thing you should check is reduce. Does 3 go into 243? Let me ask you something. What's 2 plus 4? What? What's 2 plus 4? What's 6 plus 3? So 3 goes into that sum, 9. So guess what 3 goes into? 243. How many people have heard of that rule, dividing by 3? I'm going to throw this podium. 1 student? 1. It also works for 9. 9 actually goes in that number as well because 2 plus 4 is 6. You're lying, Owen. You knew that from last year. You just didn't raise your hand. You know about you don't remember the divide by 3 or divide by 9 rule? Huh? What? He just gave me a bunch of weird looks. Anyway, so 3 does go into 243, and then who already figured out what that answer is? Well, how many times does 3 go into 243? 81. So look at how reducing 3 times root 1 is 3 actually led to now rooting. And then I never have to rationalize. What's the square root of 81? 9. So this became 3 times 4 times 9 on the bottom. No radical anymore. One more reduction, and I get 1/12, and I never had to rationalize. Never. That's why the root it and reduce it, you want to do that first. I always get sad when the students start rationalizing right away and multiply top and bottom by 243, and then they get this ginormous product, and this maybe on a no calculator test, they've created their own problems because they did not choose the most efficient method to simplify this. This goes a little bit farther than we really need to, as far as what's going to happen to you with trig. But I will do the last one. 7 perfect square, yes or no? 150 perfect square, yes or no? No, is there one in there? Do you think 7 goes into 150? Doesn't feel very good. So this one's a real ugly one. You do not want to rationalize right now. You do not want to multiply top and bottom by root 150. You want to do this. Hope we're still paying attention there in that back corner. Tension spans. Hey, lunch lady or person. How many quarters are in a $1.50? This always makes me sad to figure this out. How many quarters in a $1.50? 6. So I just broke down 150 into 6 times 25. Why did I do that? What's the square root of 25? And then the next thing we're going to do, we're going to kill 2 birds with 1 stone. We're also going to rationalize. We're going to rationalize. So we are getting the perfect square, and then we're going to rationalize this situation here. So root 7 times root 6. Why is that done? 7 is prime. 6 is 2 times 3. Those are all prime. So 7 times 6, 42. Nothing can break out. And then this is 3 times 5 times 6. Again, some reason mathematicians hate radicals in the denominator. And then, of course, we have to multiply these. I do 6 times 5 is 30. 30 times 3 is 90. This is ugly. Too much. But I just thought I'd still go through it. Okay, now, back to this. I'm not doing all of these either. I gave you trig here. This is why the math teachers, other ones, were afraid of this. It's really the third one. Solve for the missing sides. Identify the 6 trig functions. By the way, don't do this one, but just verbalize it. Blank 12, 13. Who knows what the blank is from our Pythagorean triples? Who said it? Say it out loud again. Okay, I could have heard someone say, no, nobody remembers your Pythagorean triples? These things that we cover. I know it was Monday. We had 3, 4, 5. I believe this was the next one, blank 12, 13. All right, what's 13 squared? I bet you someone knows that. Oh my gosh. Nobody knows 13 squared. What? What's 13 squared? I got a bunch of seniors and juniors in this class. I don't even know what 13 squared is. 169. If you don't get this one, here comes the podium. What's 12 squared? Oh, at my back. All right. What's 12 squared? 144. Thank you. What's 169 minus 144? What's the square root of 25? So I ask you one more time, blank 12, 13. What's the blank? 5. 5. By the way, 3 root 2. This is a 45, 45, 90 in disguise. You're going to have to know that pretty quick here coming up. But I'm not doing any of those. So what if you can't find them? You use what's called the P, P, Y, P, Y, T. Pretty Young Thing. No, who knows that song? Nice. Okay. By the way, angle A, this means that's side A. Angle B, that means that's side little b, right? Do you guys remember that? C, this is side little c. Do you remember that? We don't remember anything. I don't know. What's the square root of 25? Yay, we got something. All right, plus a squared equals, what was this theorem, by the way? Pythagorean. That wasn't Pretty Young Thing. Okay. All right, so a squared plus b squared equals c squared. The hypotenuse is c. All right, and then this is where this is going to be annoying. This comes into play here. Okay, then how do you square 9 root 2? You square 9, you square root 2, and then you do that product. Okay, so that's how you square 9 root 2. All right, all things we should know. And then a squared equals 2 times 81 is 162 minus 36. This is a note thing. This is not in your homework. And then this becomes, I believe, 126. And then you root it. Now watch how I broke this down. Whoa, whoa. 2 times what equals 120? 60. But then it's 63. And then 63 is what? 9 times what? 7. And I stop. What's the square root of 9? And then 2 and 7 are not perfect. So what's 2 times 7? So it's 3 free, 14 unfree. That's how you do it. And I actually like it because I got the biggest perfect square identified once I took a 2 out and then I saw the remaining product. Square root of 9 is 3. Everyone can answer that. Square root of 2 and the square root of 7 don't simplify, so they're stuck and they must multiply together. Now, the 6 trig functions is quite annoying. What's sine? Sine is what acronym? So, by the way, this is another non-coordinate trig question. We end when we put a triangle in a coordinate plane. So there's a difference, and understand those differences. By the way, who's the reference angle? It's here. So who is the opposite side? Which is 3 root 14, and then this is why they were worried. 3 root 14 over, what's the hypotenuse? 9 square root of 2. Now we should know how this happens pretty easily. 3 over 9 is 1 over 3. And then root 14 over root 2 is just root 7 up on the top. Because root 1 on the bottom is just 1. So that's why they wanted to go through all this when you have questions that this happens. Okay, and then cosecant is the flip of this. And then take that answer that we got and flip it. Then I swear to dog, you should get good with this, that this is 3 root 7 over 7. Because the same thing, I got to multiply top and bottom by root 7 over root 7, and then I get 3 root 7 over a free 7. You should not have to keep writing in this class multiplying by root 7 over root 7. Okay, but as you get practice with it, maybe at the beginning, go ahead, but then at the end, should be fast. Cosine of theta, I think you know, is adjacent 6 over 9 root 2. This requires a little bit more. 2 over 3, and then I have to rationalize with these root 2's. So I did go against myself and say I'm doing what I said you should not have to do anymore. But when you have multiple steps going on, maybe it is good to write the work. I should be able to go over this fast. Rationalizing a denominator should not be the thing that's like, oh my gosh, this is blowing a brain gasket. And then root 2 times root 2 is 2. 2 times 3 is 6. Unfortunately, I have one more reduction. So a bit of an annoyance in this question. Like 3 different things I had to do. I had to simplify, I had to rationalize, and then I had to simplify again. Yeah. Okay, and then you take this one and you flip it for secant. Secant of theta is, I think many of you will be this fast. Oh, when I flip 3 over and make it 3 over root 2, that's 3 root 2 over 2. 3 over root 2, multiply both top and bottom by root 2. That's how I get 3 root 2 over 2. Okay, and then tangent, I think we get the idea. Tangent is this over that, and then flip it for the other one. We get the idea. I want to move on. Okay, I want to move on. Right, that's all kind of review, and the other teachers were worried of it. Okay, now here's what 1-4 is about. Remember, turn over your worksheet. I want 1-4's bookwork back there. Understand what every multiple of 3 means. All right, and I try to just pick a couple of different questions from this section. One of them is, and I don't think you should write the bottom part of this, the idea of reciprocals. Reciprocals are flips of each other. So this has already been established. Sine is so. What's cosecant? Oh, all right, because it's H over O. So what's true in identity world, and we are going to have identities in chapter 5, then these mathematical statements are true. Sine of theta equals 1 over cosecant of theta. And if that's true, then the flip of this is true. Cosecant of theta equals 1 over sine of theta. But we don't really need these until identities. We just need to know that they are flipped. You don't necessarily have to write all this down yet. Chapter 5, this is going to have to be memorized and used. Math 3 honors. Anyone in here? I don't think I grabbed the math 3. You remember identities? That was a big chapter. Identities chapter is usually the big kind of hit in the road here. And we don't need this till chapter 5, though. But if these truly are reciprocals of each other, then their product equals 1. Just like these are reciprocals of each other, and their product equals 1. So it might be nice to knows right now. In chapter 5, it'll be a need to know. Here's how it shakes itself out in this section. So the idea of reciprocals. We already know this. I already did it in the last question. If I tell you secant of theta, and you can almost see through that, by the way, secant of theta is 5/3, then what's cosine of theta? 3, 2, 1, go. 3/5. It's ridiculous. Now, the next one's annoying because of radicals. What's wrong with this one when you have the square root of 12? What is 12? What times what? Don't say 2 times 6. It is 4 times 3. What's the square root of 4? Everyone can answer the square root of 4. Why it gets into a question like this and it becomes a challenge, I have no clue. It is a mathematical, I don't know, conundrum. Why students blow brain gaskets on simplifying radicals. One more time, what's the square root of 4? 2. So this is cosecant. I'm doing this because this one's annoying. Square root of 4 is 2, and then these cancel. And now what's the sine of theta? The flip of negative root 3, which is negative 1 over root 3, which equals, anyone, real fast? Negative, this is terrible, root 3 over a free 3. Oh, boy. Okay, so let's go ahead and just multiply top and bottom until they get that figured out. All right. I hate these questions, though. They're not really that massively important. They should be, if I have 2 questions on the test Friday, the test is Friday, by the way, that should be 2 points for everybody. I think it's 2 points a question, so that'd be 4 points for everybody. All right, should be. All right, now here's the next one. This is called a mnemonic device. Roy G. Biv, what is that for? What's that mnemonic device for? Colors of the rainbow. All right, so this is a Roy G. Biv here, and you might want to write this whole thing. I stole it off the internet. All students take calculus. All students take calculus. Okay, what that means is, and anyone in Math 3 Honors, I hope to gosh your Math 3 Honors students or teacher did this, is this is who's positive in what quadrants. So spend a minute to do this. This is another thing you should write on your test then. You should write SOHCAHTOA, Sir Kicks or Ticks, and then all students take calculus in a quick coordinate plane that I'll show you after this. This is a really specific one. But what I love about this drawing that I stole off the internet is they show the coordinates in action. So now I'm gonna do it. Just humor me. The 1-3 notes, no coordinate plane. We just had a triangle. We had a triangle floating around here. There were no negative values. You just did SOHCAHTOA. All right. In section 1-4, I told you the whole big deal about section or this new trig thing. It's coordinate trig. You're in a coordinate plane. So the triangles get thrown in a coordinate plane. So therefore, an X or a Y or both could be negative, depending on how you move. So if you're in quadrant 1, you go right X and up Y. Those are both positive, and R is always positive. So all students take calculus means all trig functions of quadrant 1 angle measures become positive ratios. All of them. It's impossible not to be. So then what students? Who's the most popular and only trig function that starts with S? 3, 2, 1, go. Sine. Students is the mnemonic device for sine. All students sine. Sine and its brother or sister. Sine is so, cosecant a ho. These are the only two that are positive because sine is Sir. So therefore, cosecant is R over Y. And in quadrant 2, only Y and R are positive. Cosine, secant, tangent, and cotangent have a negative ratio then. Those first two are positive. We have a fumble. We have a question. Go ahead. On the bottom right? Oh, it is. Thank you. Holy smokes. We do have it's correct up there, but incorrect down there. So nice. X comma negative Y. Oh, 6 hour didn't say a word. Thank you. All right. And then third quadrant, negative X, negative Y, left and down, are always positive. Ticks. That's why tangent of an angle measure deals with negative over negative, which turns into a positive. And then cotangent. Last one, nice change. Thank you. Calculus, X right, positive, Y down, negative. Kixer, cosine, that's what calculus stands. Don't confuse this. There's also cotangent. Cotangent's a new one. That was brand new to you this year. The original, all students take calculus cosine. Cosine is positive in quadrant 4, along with its brother or sister secant. And I think I have that cut off there. There we go. Okay, now I'll show you what kind of cryptic questions they have on this. This is on the no calculator part. I'm literally telling you test questions here. Actually, it almost always happens. What we assign for homework and we do for notes, these end up on the test. And I guarantee you'll have 2 of these. And I'm going to change this one because I hate this one. I've dealt with this one over the years and it doesn't have anything special. So I'm going to change that one to tan. Worded exactly the same way, but I'm letting you have the directions here first. Identify the quadrants or possible quadrants of an angle theta that satisfies the given conditions. Again, students don't get this because they don't understand well enough. You sign an angle measure, and the answer is a ratio of sides. So this actually represents a ratio of sides. So does tangent of theta represent a ratio of sides. You tan an angle, and it ends up being a ratio of sides. So is that ratio, or what ratios would satisfy these conditions in the given quadrants? Here's the first thing you should do. Here's what you should write at the top of a test. SOHCAHTOA, Sir Kicks or Ticks, and then ASTC. As a matter of fact, you almost have time to write that in every question just to make sure you have your signs correct. Okay, really large. Okay, then what does this mean about sine? And I'm going to color. By the way, what does yellow and blue make? We're also doing colors today. Green. So watch this. What does this mean about sine? Sine is greater than 0. Does that mean I don't have the time for this? Positive or negative? 3, 2, 1, go. So the ratio of sides is positive. Sine of angle measures is positive in what quadrants? There's two possibilities. 3, 2, 1, go. One for sure. All are positive in one. And then that's exactly what this means. Sine is also positive for quadrant 2. So right now, theta could be in 1 or it could be in 2 where it lands, the angle measure itself. Okay, now what does this mean about tangent when it's less than 0? What does that mean? Tangent's what? Negative. So here's how we do this. What do yellow and blue make? Okay, I'm not marking this yet. Where is tangent positive? What quadrants? 1 and where's tangent positive? 1 and where's the dang T at? 1 and 3. So that means it's negative in 2 and 4. Yellow and blue make what? For both of these to be true, where does theta have to be in? Quadrant 2. For both of them to be satisfied. Okay, so that's this kind of question, what they're trying to get you to understand. That's the whole question. You don't even get to find what theta is. Okay, so let's do it again. Cosine of theta is less than 0. What does that mean cosine is? Positive or negative? No time for this. And then tangent of theta is less than 0. What does that mean tangent is? Okay, so here's how we got to do this. We got to do a little reverse thinking. ASTC. Let me get the yellow. Let's answer first. Where's cosine positive? 1 and what? 4. Here's the C. So where is it negative? 2 and 3. So guaranteed that cosine of an angle measure in these quadrants will result in a negative. Okay, now let's go to tangent. Where is tangent? Let's do the opposite, positive. We should get this right because we just had it. 1 and 3. So where is it negative? 2 and 4. And actually, I'm doing a bad service. I'm doing 4 first, then 2. You know it goes 1, 2, 3, 4. Some students don't know that well enough either. They get their quadrants all screwed up. I can't write. That was not the pen. That was me not hitting the screen there. I like to blame the pen for everything, but Friday was terrible. But then today I got a low battery message. So maybe Friday was because of the battery. I'm hoping, right? And then I could stop complaining for a while. All right, so again, this one was a quadrant 2, theta in 2. All right, one more annoying question. This is on the no calculator. And it's going to be maybe a little bit different than this, but on the no calculator, sine of negative 213 degrees, what does that equal? And then it's either positive or negative. That's it. So it's a 50-50 choice. So that's all they're asking. Sine of negative 213 degrees, what can you expect, a positive or negative answer? Well, very simple. Where does negative 213 land? What quadrant? It actually is 2. And those that got that fast, I appreciate you. Hopefully you did do it this way because this is negative 180. So negative 213 lands there. That's negative 213 degrees. And then if you put ASTC, what can you expect? A positive or a negative answer? What's S stand for? What's S stand for? Sine. And what is it saying about sine of quadrant 2 angle measures, positive or negative? Positive. We can expect a positive answer if I type this on my calculator. Okay, and then that's another kind of silly question that they ask of this. All right, and I'm only going to do one more question. I'm going to skip this section. I'm going to go ahead and do this one. All right, and then we'll call it a day. Now, again, this is different than this question. What do you have here? No coordinate plane. So we just do our SOHCAHTOA and don't even, circ kicks or ticks doesn't even make sense because you're not in a coordinate plane. This question, okay, I got to go back to it. This question I'll leave up here for you to take down as notes, and I'm going to end with it. This is how your homework ends. I have like 4 of these for you to do. And then this is why the math teachers, the cat teachers, were worried about rationalizing. Okay, suppose that an angle theta in quadrant 2. See, now we're in a coordinate plane. And sine of theta equals 2/3. First of all, isn't that supposed to happen? Quadrant 2, we have a positive ratio, right? Okay, so that's kind of like trying to tie in together what I was trying to tell you with ASTC. Okay, the problem is you should really draw this. We've already done questions like this, I believe, but maybe this is a little bit different. By the way, this being sine, what side is this then? And what side is that? Okay, well, I'm talking about opposite, adjacent, hypotenuse. So what is 2? Opposite, adjacent, or hypotenuse? Opposites. How are they getting that? So what does the 3 represent? Hypotenuse. And I can at Lockport, I can stick with 2 and 3 being opposite and hypotenuse instead of circix or tix. We really only need that when we don't have a coordinate plane, when we don't have a triangle, which is the quadrantals. So you can survive with this. But what you can't survive with is not putting a what kind of number on this when you have to go left and then up. What kind of move is left? Negative. So that you might want to do that right now. Okay, before you continue and find what that missing value is. All right, so then x squared, we've already had these kind of questions. Now it's a Pythagorean theorem thing. And please be fast with this. I don't know why I did it. Sometimes speed kills. Did that, it's supposed to say equals r squared, which is 3 squared. 3 squared is 9. What's 2 squared? What's 9 minus 4? So x squared equals 5. When you square root both sides, you're supposed to put a plus minus in front of this mathematically. Which one is it? Plus or minus? We just said it was minus. This is the biggest missed thing, when doing this stuff. Not putting the negative there because we're in coordinate trig. Or also ASTC, AS, only sine and cosecant are positive. And by the way, we should have been able to find cosecant right away. If sine is 2/3, what's cosecant? 3/2. And then now we got to go into the rationalizing. By the way, not to speed this up too much, that's theta. This is theta prime. So that's how I play SOHCAHTOA. That's why that's the opposite side. That makes this adjacent. So cosine's not bad. It's negative root 5/3. I can't zoom in too much more because then I cut off my long set of fractions here. And then this is negative 3/root 5. This is what the other math teachers were worried of. Can students rationalize? All right. Multiply both top and bottom by root 5. You get negative 3/5/5. I already showed you rationalization. We should get fast with it eventually. And then tangents TOA. So this first one's annoying. TOA, which is negative 2/root 5. Hey, you'd be smart to do cotan right now. That's rationalized. So I'll flip that now. Then I'll go ahead and rationalize tangent, which is negative 2/5/5. Okay, and again, we should know how to do that. Multiply top and bottom by root 5 from our previous examples. Okay, I want to be done, and that should be good. And then we're actually done. Today's Tuesday. The test is Friday. So we got Wednesday and Thursday to clean stuff up. Clean up. Everybody do their share.